Welcome to this session. The title of this session is Azure Synapse Link for Cosmos DB, and we are going to talk about Synapse Link in details. Also, we'll touch base on best practices. My name is Manish Sharma. I'm part of Cosmos DB engineering team. I'm working as a principal program manager. I have Sandeep with me.
Hi, folks. I'm Senior Program Manager from Cosmos DB team, and I work with the Cosmos DB engineering team. Thank you.
Hey, Sandeep. So without spending any time, let's deep down into here we have two scenarios. These are typical scenarios when you have ingestion of data into OLTP store, which is Cosmos DB, and then you have another scenario where you extract the data from Cosmos DB and you store it into data lake. From there, you perform offline processing. So both the jobs requires heavy read from the OLTP store, which creates challenges in terms of impacting their OLTP reads as well as writes, and you need to do a lot of management overheads. So here's the solution we have introduced. It's been long that we have introduced this. So this is the magic we do behind the scenes. So we connect Cosmos DB and Synapse using Synapse Link. And this way, you don't need to worry about your cost, no need to worry about the ETL and performance impact perspective, which is very critical here. It's not there, and at the same time, data engineers and machine learning team is super happy to know that they are getting data almost in the near real time basis. Here are the set of benefits which I'm summarizing here. So I'll start from the one which I touched base in the last. So your data is available onto analytical store in almost near real time. So less than 2 minutes of the gap will be coming in. Benefit, of course, the cost benefit in terms of no RU cost while you're reading for the data movement. That data movement itself is managed, so you don't need to worry about from that perspective. All the cost reductions will be available. I'll talk about it in details in few slides later. And then the best of both worlds. So you have Cosmos DB operational store where you are getting best breed of the performance. At the same time, you are able to connect this into Power BI and using Synapse Analytics for your offline processing. So you may prepare the data and then you can show it over the dashboards of Power BI. Because your data is available onto Synapse Analytics, hence you're able to use T-SQL language. Full compatibility will be there, so you don't need to worry about from that perspective. And last not the least, but you can actually modify the data in analytical store, and you'll be able to perform your simple queries or offline processing. Now, of course, you'll be wondering that how it does the magic. So here's the thing. So this is existing. So you have Cosmos DB where you have transactional store, and you are getting all the data in Cosmos DB stored, and you'll be able to perform your operational queries on top of it. And then this is the magic which we have introduced under the hood of Synapse Link. So this data which you ingested onto a transactional store, it's automatically moved to analytical store, and you can see the direction changes. Analytical store is column store ready for analytical queries. It does do the compression, and this movement is completely managed by us, as well as we do auto synchronization. How you can perform queries on analytical store is using Synapse Link, and you can use SQL Serverless Pool, or you can use Spark to perform your offline jobs. So it could have machine learning, big data, Power BI dashboard, etc. When you enable Synapse Analytics. So what you actually get is this. You have auto sync, so all the data is getting moved to analytical store at a frequent interval. Minimum is 2 minutes, and then this is completely managed, so you don't need to worry about downtime. One of the important thing which actually makes it more overall proposition more attractive is basically no performance or cost impact on your transactional workload. So it will not impact your transactional workload here because the entire data is getting copied to analytical store here. So you'll be able to perform your batch queries or humongous queries for aggregation or analytical purpose. It will not impact onto the transactional store. Um, this is very important point that automatic schema is getting inferred by analytical store. Hence, you don't need to jiggle around. However, I'll discuss the best practices around how to go about it. One of the thing which is uh, um, which is available with Cosmos DB Analytical Store is basically Cosmos DB globally distributed. You know that you can configure multiple regions for Cosmos DB. So all the regions will have Analytical Store enabled. So as soon as you enable, so your analytics is also replicated across the regions. So that's the value addition Cosmos DB also provide on top of regular analytical store. Now you have TTLs. So you know time to live, and time to live is basically used for removing the data which is not necessary. Now all the data is necessary, so you need to have it in some form or shape. So what you need to do is you as soon as you enable, you have a copy of the data in analytical store, so you can get rid of the data, the data in operational store. So you can have lower TTL in operational store and maybe have higher TTL or no TTL on analytical store because anyways the data is available there. Here, multiple use cases. I'm just highlighting here. So retention, you have mirror, and you can basically have expiry of the items in analytical store. Other than that, here uh, the important thing is that let's say in Cosmos DB you already have multiple APIs. So we are supporting as of now SQL API by default because it's a core API. Also, we are supporting MongoDB for analytical store. Here, we use we basically use analytical store for inheriting the schema from polymorphic MongoDB BSM, and it is completely full fidelity. So all the changes will get replicated to cross analytical store. One of the thing I just wanted to highlight here is that let's say if you have schema incompatibility, in one case you have string, second case you have integer. So this is the example how it will create two different columns for the same. However, we recommend you to stick to one data type for one field that will actually give you much better consistent things. In case of arrays, you basically get the full JSON, and that's how you are able to perform the further queries here. There are some limitations, of course. 200 properties is what we support right now, and maximum depth of the schema could be 5 level. So here's the example. So let's say if you have level 1, 2, 3, 4, and 5, this is something that's not supported. Hence, you need to look at something which is basically lower down the line, because this is the guy who is basically going into 6 level. So 5 level, yes, but 6 level, no. One of the important thing that you need to keep in mind that when you have Cosmos DB, the name of fields are case sensitive. So those fields are unique. Like if you take this example, then both the fields are unique in Cosmos DB. However, because analytical store does not have case sensitiveness in column field, hence this is duplicate for analytical store. So what you need to do, you need to make sure that you have a different naming convention for different fields rather than just changing the schema name. Okay, I told you that I'll speak about the pricing, which is one of the major advantage of this proposition. So let's say you enable analytical store, you'll be able to get this data stored at the cost of 2 cents per GB, wherein you're already paying for transactional store at 25 cents per GB. And the reads and writes are further cheaper, just like block storage and ADLs Gen 2. The cost is super cheap. So 10,000 transactions is zero point 0.5 cents. When you have read, you have 10,000 transactions for 0.005 cents. And SQL Serverless pool, you can consider the additional cost. That cost is again cheaper. It's basically on-demand pool. You can go for $5 per DB, or you can go for Spark pool, which is 0.6167 per week or per hour. That's total cost. And on-demand cost, because let's say if you are performing just processing, not every minute or every second you need to perform it. So you have a fair advantage here. You can reduce the compute whenever there is a need. You can actually have that. Furthermore, analytical store has compression, which is up to 5x. It does manage indexing, as well as it has a UTF coalition, which both in combination reduce the the data reads. So you will basically be able to have a lesser cost in terms of unit. Here's a simple pricing comparison. So you have a combination in one use case. Let's say if you have this use case where you have OLAP as well as OLTP, which means that you have enabled Synapse Analytics on top of Cosmos DB. Hence, what you'll be getting is you have some data in OLTP, and then you have most of the data in OLAP. So here 5 terabyte and 100 GB is what we are considering. The cost is coming as $359.91. And then on the OLTP side, let's say if you don't enable Synapse Link, then you have to have all the data into OLTP. And then the cost of 5 terabyte OLTP will be humongous, which is 4,270.41. What you will be getting is basically somewhere close to 63% cost reduction with Synapse Link, and that's how you will be getting the advantage. So this is just a high level comparison. We have just taken one example. Let's say if you have your own use case, feel free to perform simple calculation using capacity calculators. With that, we are going to talk about the Contoso mobile billing application demo. I would like to hand over to Sandeep, who will take us through this demo. Sandeep, over to you.
Thank you, Manish. I'll just share my screen and then we get started. I hope you can see my screen.
Yep.
Okay, so let's get started. So what we're going to see here is a demo where we are going to see Contoso mobile billing being managed through Cosmos DB. And the problem statement that was provided is that we need to be able to log all incoming and outgoing calls. Then the subscriber should be able to view the recent call history using their calling application. And then there has to be a monthly bill that gets generated for all the calls that get originated from the mobile network. And last but not least, the Contoso team should be able to look at all the call history and do some analysis for business improvements and offers. So with these 4 problem statements, we came up with a solution design. And the solution design is very basic. Basically, we are saying we'll create a service that will integrate into the calling app of the mobile network. We understand the calling mobile app requires to have a service which is always available, which should have a very low level of latency. Since the customers are going to be anywhere in the world, we need our service also to be geographically distributed. And since we are talking about millions of customers making call at the same time, yet we need a service which is having a high throughput. Since all of these are perfect candidates for Cosmos DB, we are going to use the Cosmos DB for as the backend database for this service. Now for the data analysis and the monthly billing jobs, that's where we are going to bring in the Synapse link, and we are going to use Synapse for doing these two activities. So we are going to have Power BI, which is connected to Synapse link to run our business analytical jobs, and then we'll use Spark to do some batch jobs and generate our bills. So let's see how this we will be doing using the HTAB. So here you see on the left-hand side, the real-time calling application is generating a lot of data. It is generating all the call logs, and we are going to store that data into the row store of Cosmos DB, whereby we get the powers of Cosmos DB, which is low latency, high throughput, and globally distributed. The data model that we are going to use here is also going to be optimized for data ingestion for high performance. Under the hood, Cosmos DB does the magic and converts this row store data into a columnar store data, which will be used for analytical purposes. And that's just the Synapse link part. Once the data is converted to the columnar store in it will be used by SQL serverless for doing the Power BI dashboards. And then we'll be using Apache Spark to use the same data for doing some batch jobs. So by doing this, what we get is we get the best of both worlds. We use the row store or the transaction store of Cosmos for all the fast, high throughput activities. And we use the analytical store for all the backend activities, thereby getting the power of SQL and reducing the cost of operation. So let's see the data model that we are going to use for ingestion. So our data model, we have kept it very basic. We have some information about when the call started, from where did it get generated, to which call it get, where will the call end, etc. But from right now for the demo, we are going to take three fields which are key fields. So we are looking at ID, which is the unique ID that is generated by MongoDB here. We have a subscriber ID, which is the identifier for the person who is making the call. Then we have a bill cycle, which is the month followed by the year, which is an auto-calculated field based on the date and time. And then we have the PK or the partition key, which is a combination of subscriber ID and the bill cycle. The partition key here is important because it decides how the data will be partitioned and stored in the database. We have used a partition key, which is a combination of subscriber and bill cycle, such that at any point in time, the data will be picked from a single partition. The data will be equally distributed across all the partitions, and we ensure that there are no cross-partition queries. Also, as Manish mentioned, we are going to use TTL here to reduce our operational cost. So by applying a TTL, what we are able to do is ensure that the data is retained in the transaction store only for the period that you need to have it, and for your data to be available for historical records, we maintain it in the analytical store. This is the data model of the bill document that we are going to generate. This will be generated through our Spark job. Here we have the ID, which is the subscriber ID followed by the bill cycle. It happens to be the partition key also. We retain the subscriber ID as it is, and then we have a field called cost, which is a calculated field here. This will be calculated from a Spark job. Then we retain the list of all the calls that happened in that bill cycle in the form of an array here. So these are the details that we are going to generate through our Spark job. Now that we have got introduced to our data model, let's quickly jump into the demo. So to generate data or do the call login, I have created two console applications here. These are just going to dump some data into our Cosmos DB. And so before going there, let's just quickly go into our database and make sure that it is empty. So this is our call records. Let's just refresh it and see if it's empty. Yeah, it is empty. So we will run these applications one by one and generate some data. So the first application is generating 15 call records. The second one is generating some 101. Let me run this again. So that we have some decent data. We will very soon have 130 records in Cosmos DB. So yeah, we have done. So let's go back and refresh Cosmos DB and see what happened. Yeah, so we have the data here. We have about 130 records. Let's just open a few records. So we see that the data is in the form, in the model that we discussed. Just to explain again, just to share the code here, what we are doing is we are generating a fake document using the faker library and then using the insert many function of the Mongo driver to insert those objects. So it is very basic, nothing special happening in this space. Now that we see that the data is inserted in Cosmos, let's see if we can see the same data available through this view. Yeah, so we have 130 records here, and you will notice, but what you would be wondering is I inserted data into Cosmos DB, which is a NoSQL database. And here I am in SQL and I'm executing a view and I'm seeing the same data. How did this happen? Well, that's the magic that Synapse Link brought in, and let me explain that step by step. So let's now switch into Synapse Link and see how it happened. We will go into the SQL script here that we have developed in Synapse and see what happened. Firstly, to be able to use this SQL script here in Synapse, we need to add the database as a linked database. So we go into data, we click on linked, and then we click on plus, we click on connect to external data source, select the Cosmos DB from here, click on continue, fill up all these details. And by doing this, we connect we bring the Cosmos DB into Synapse Link. So I have already done that here, so I'm going to skip that step. Once the database has been added, you can see that it shows up as a linked database here. And if you open the database, you can also see the columns here, and you will see that the icons on the two columns containers are a little different. So since we have enabled Synapse Link on the call records container, we can see that it's showing some columnar icons here, whereas the bills column container is not linked. We have not enabled Synapse Link, so it is not showing any icon here. Now, to be able to use the Cosmos DB in Synapse Link, the first thing that we need to do is to generate a credential. To generate the credential, we use the create credential command here, and we pass the password secret to it. The secret is nothing but the primary password that you find in your Cosmos DB console. So you run this and it will create a credential for us. I have already done that, so I'm going to skip that step. Once the credential is created, I can connect to Cosmos DB using the open row set function here, and it takes in parameter of that. The type is going to be Cosmos DB. It's going to take my connection string in terms of my account and my database, and it's going to ask for what is the credential that I'm going to use, and I pass the credential that I had created. So let's just execute this query and see what happens. So we see the data, but again, we see that the data is coming in JSON format. All the columns have got some data in the JSON format. This is because of the full fidelity that Manish was talking about. When we bring data from MongoDB to the analytical store, we get the data with the data type, this allows us to read data in the right data type, even if there are two columns of the same data type available in the JSON structures. So now the question is, how do I read this? Because this data is not in a format that I can readily use. I cannot run a query on this. So how do I convert this into something which can where the data can be used? So to do that, we use the with clause, and in the with clause, we provide the column name, the data type, and the path in the JSON from where this data has to be read. So for example, when we have to read a simple thing like this, we provide the column name from where it has to be read and the dot date object, because that's the date. Similarly, if I want to show you here, let's say, device. In the device, it's a far longer, it's a complex JSON. So here you will see it is as device.object.os.string. So I can give a complete path, and by doing the path, I can read it in an appropriate format. So let's just run this query and see what's the difference. So now the data is all cleaned up. It is coming up just like a regular RDBMS query, and now this data can be used for any joins or filtering or queries or etc. So for example, I could have added a bill cycle query and filtered this data. But now the question that comes up is, okay, this is great. This is a SQL query, but this is inside Synapse link. How do I use it? How do I put it into use in my application or in a third-party application? Now, for doing that, we need to take this query and convert it into a view. How do I do that? So for doing that, we can create a database in Synapse link. We use a create database name command to create a database. So once you create this database, you will see a database showing up here. I have already created the database, so I'm going to skip this step. And then inside this database, you create a view just like you create normally. And what we are going to do is we are going to use the query that we saw above and then run it, and it will generate this view for us. So once you create this view, it is a view available in this database. So let me just switch back to SQL Server and see it. So this is the database that we created, and it created this call records view, and it is a regular SQL view. And once I execute it, it's going to get me the data. Now this view can be used in any application that you have using whatever methods that you already know of. And what we are going to do is we are going to use it in Power BI and see it in function. Also note that here the database server ID is on demand SQL. So it is not a dedicated SQL, it is SQL serverless. So whenever you fire a query, it runs the SQL on demand and generates the results and gives it to you. So let's go to Power BI, and in Power BI, so I have created a small Power BI dashboard here, and let me just refresh it, and it uses the same view, and let's see what happens. So you can see that it's connecting to SQL serverless, and it got some data, and it has generated this query. Now this data is running all inside Power BI using the SQL view, and it is not working from the transaction source. So your costs are low, but you get all the benefits of using an analytical store here. So that's scenario number one that I wanted to demonstrate, where we saw the data coming from Cosmos DB to analytical store getting utilized in SQL serverless. Now let's get into the scenario number two, which is how do I do some batch processing? And for that, we are going to use a Spark Synapse Spark document. So what do we do here? In this Synapse Spark notebook, what we are doing is we are going to load the data from our OLAP store into a data frame and then do some data processing activity. So the first step is to load the data from the Synapse link to the data store. And here we have done that. You can see that some data has been loaded. Next is let's look at the data schema. Let's study this data schema. So as expected, here it's again the full fidelity schema. You can see that the data has been read in its full fidelity. All the data structure is maintained. So now we need to unpack this data and convert it into a format, into a data row format or a data frame format, so that we can do some queries on it. So for doing that, we use the df.select and provide the path here to read from where the data has to be read, and we then convert it into a unpacked data format. You will also see that after unpacking, I am applying a filter right upfront. This is to make sure the data is filtered at the first step number 1 to for optimal performance. So as we see, the data that you saw on the above has now been unpacked, and it is now a filter has been applied on the build cycle, which is for June 2022, and we have the data in a data frame format. Now, once the data is there, let's use that data to generate our bills here. We are going to calculate a cost. So we are doing some data operations by putting a formula of calculating a cost for incoming calls versus a separate cost for outgoing calls. We kept it very basic here, but basically this would be your business logic. So once I do that, you will see that it has generated an aggregation based on the subscriber ID, and it has calculated a cost for each subscriber. So this is our bill amount that we see. Now once we have calculated the cost, we need to write our bill document and push that document back to the Cosmos to be a transactional store for further processing. So let's get into doing that. Now, to be able to write into Cosmos DB transaction store from PySpark, we don't have a direct library available, so we are going to use PyMongo here. So we need to load PyMongo as an external library and then use it. There is a step given on how to load a third-party library to Cosmos Link here. I followed these steps, and we have loaded PyMongo into this Synapse workbook. Now, once you have loaded the library to the workspace, to just make sure that the library is right, you could use these commands to check them. So when I run them, it is going to check if the library is available or not, and it will give me an OK if it is available, and if it is not, it will tell me it's not available, and then I could accordingly debug. So in my case, my environment is ready, the libraries are loaded, and now I'm going to start writing my data into my Cosmos transaction store. Again, to write it, I'm going to use my account name. I'm going to use my write string that I have got, and I'm going to tell which collection I'm going to write. I'm going to use the PyMongo classes to create a Mongo client and then authenticate here. Sorry, I forgot to run these lines, so it's not initialized. And now I'm going to run this. And it got initialized, authenticated here. And now what I'm going to do is I'm going to use my data aggregated data frame, which we saw here on the top, which is this one. And I'm going to loop through each record here. And for each record, I'm going to create a build document, and as an embedded document, add all the call records that are relevant to this subscriber. So for doing that, I am looping in the data frame. I am adding the call records as an embedded JSON object here, and then I will create a document, JSON document here, and then using the insert one function of the PyMongo library, I'm going to insert those into my bills collection of the Cosmos DB transaction store. So now let's run this, and it's going to loop through all those 10 or 12 subscribers and then generate the bill document for them. So it's done here. And now let's switch to Cosmos DB transaction store and see what do we see here. So now we have the bills document here, and if you open the bills collection, I can see that there are bills that are getting generated here. And each bill has got the ID, the subscriber a cost which was calculated and then logs. So depending on which subscriber made how many calls, you would see that much as the amount at the cost as, and you will see each call and the log entry. So what we saw here is again a scenario where data was generated in Cosmos, was copied by Synapse link to the analytical store, which was picked up by the Spark job. It did some data processing and it has created a materialized view of the data and stored it back into Cosmos, but using very low cost and also not utilizing the resources that were otherwise would have got blocked for the transactional activity of Cosmos DB. So let's just look at what we saw once again. We saw that by using the Synapse link, we could use a no ETL based data transformation. So it's reduced the cost and complexity. There is no impact on the operational workload. We were able to see the data moving from the transactional store to the analytical store almost in real time. It takes approximately 2 minutes, sometimes less. It is very cost effective because you do not have to worry about building your own ETL pipeline. It's all built into the Cosmos DB system itself. And also you do not spend RUs for data processing whenever you're doing things in the backend. It's all happening using the compute of Synapse and SQL serverless. Also, your data is getting loaded locally from a globally distributed multi-region environment, but you could be doing all your backend processing from your central server. So that's also built in, and you don't have to worry about the data have to be brought into a single place or consolidated a single place. So that's the demo that we wanted to show. So over to you, Manish, again. Thank you.
Thank you, Sandeep. It was really nice, interesting demo. It is all interacting with MongoDB, and one of the cool thing which I like about this demo is how you extract the data, you process it, and then for faster retrieval, you push back to Cosmos DB again, and you were able to get best of both worlds. And that was a very amazing and real use case also. And let's see what other use cases people are using Synapse Link with, and how this particular offering is making their life easier. So one of the use case which I come across is basically supply chain analytics, forecasting and reporting. Here you can see that supply chain is very critical to any organization's core implementation. What they have is they generally have multiple sources of data coming in and then pushing into Cosmos DB. Here, the exactly similar thing which Sandeep have demonstrated. So you got the data in transactional store, you pushed, you enable analytical store, and then from analytical store, Synapse Spark job perform the queries, and then push back the results to Cosmos DB again. Here, the icing on top of it is basically the combination of Spark as well as ML. That's how you're able to roll into the real-time AI. And also there is a SQL serverless Spark pool which is connecting to Power BI, making sure that your the store management understands the real heartbeat of their supply chain. So this is one of the fantastic use case, and we have seen that a lot of people are able to make their life easier because of HTAP scenario. And if we go to the next use case here, it is a real-time personalization. use case where you are getting data from different APIs, and you have order processing, and based on which the customization will happen, and you will have a different experience. So this is making more engaging customer experience, because the analytics is being performed at the real time, and you are basically getting the outcome moved back to transactional store, and you are able to provide your shoppers more happier, and have real time recommendations for them. IoT predictive maintenance is another use case where you're using STAP. All the ingestion is being happening in this path. Once it lands to Cosmos DB, the data is moved to Synapse analytics, and you're able to not only use Spark, you will be able to use machine learning, and you can have a self learning models and SQL serverless pool for your Power BI dashboard aspect. And then you can further have Azure API apps, which is basically exposing the outcome of HTAP using the APIs, simple APIs. So with that, I think these are just touch base. If you want to study more, you can look at Azure Architecture Center. You will find more samples. There may be sample matching to use case. In case you have any specific question and you have come across any specific use case which you are wondering that how it can be implemented using Cosmos DB STAP, let us know. We'll be more than happy to help you here. Now, I'm moving to the second part of which is very critical part of Cosmos DB analytical store is achieving the best of analytical store, and we are going to talk about what are the best practices you can follow and how you can optimize your analytical store offering for your scenarios. So let's say if you are looking at implementing Power BI, hence these are the important factor. Make sure that you have a location, location in your consideration. So you always consider location, and then sorry, one second. You just make sure that there is a in Power BI you have a possibility to cache. You can basically cache the data so that you don't need to do a lot of to and fro, and you can basically perform some query mode in case you have any specific requirement. In case you are basically not getting the aggregated data, you are basically trying to get the full data volume. Try to ensure that you have a minimum data volume coming in, such that you don't need to basically get to full list. In that case, you can basically perform the query. Only in case of aggregation, you can basically go for direct query mode. Let's say if you are using the import mode, or you have a cache, make sure that you have a lesser frequency based on your requirement to refresh the data, so that it will be easier for your user to basically get to the latest data. And one of the key thing which generally I have seen that people make a lot of mistake is basically they return a lot of data in the dashboard, wherein those data is not 100% used by used by the user. They just wanted to look at the fraction of the data. So why to waste our compute here by pushing all the data here? In Power BI, we have mix mode where you can have full refresh, as well as you have a direct query. You can combine if based on the, you can do a cherry picking. So let's say if some tables, which is like a master table, which is not getting updated frequently, you can put them into the direct query, or sorry, into the import mode, or in some queries you can basically perform a direct query mode, which is more frequently getting updated. You can perform a schedule refresh. Of course, this is very important thing that basically come into the mind whenever you are having a quick updates. So make sure that you have a schedule refreshes so that staleness is controlled. That how much staleness you want to expose your customer with. Um, in case of let's say if you can't use analysis services, then external table is it can be used, and you can have part of your data which is not getting used, so that it will be quick to read from the a read only partition of Parquet, and that's how it will able to perform faster reads, and you will be able to get the best of both world. um, in some scenarios, you can basically have let's say if you are running a lot of different type of queries, and you have a various type of utilization, you can create multiple work services also for Synapse. Okay, so important thing here, because now we are talking about a multi-region implementation. Let's say if you have a multiple regions, and just make sure that you co-locate the data, or you pick up the right region, because it'll waste a lot of time in terms of latency between data centers, or between geographic locations. So if you look at this setup, you have users in India, Power BI tenant in Europe, Synapse workspace in East US, and data is in West US too. So why don't you streamline this and put it everything onto the India region, and that ways you'll be able to get everything together. How you can do that? You can enable Cosmos DB read-only replica, and then you can specify the preferred region list for your Power BI, and make sure that you have a Power BI tenant also available in India. That's how things will be smoothen out, and you'll have exposed to lower latencies in terms of the cross region data movement. Spark, and I'm sure that you already have the great understanding about ADLS. This is something that everyone try to optimize for. So you can aggregate, you can make sure that you have lesser on-demand executions. Instead of that, you can pre-process the data, make sure that you have a data massage in a way that can straightforward move to your users easily, whether it is for a Power BI or something else. In case you are performing external data join, so you have a Cosmos DB analytical store, and you have some data lake store also, which is a very valid use case. Make sure that you have all the data available in the same region, so that it will be easier to avoid the cross region latencies. In case of I'm sure that you have seen the code which Sandeep was demonstrating. He was using collation as Latin 1, and general 100 bin UTF-8. That's basically is there. And one of the screenshots from his sample, I just take it. This is basically he had referred at multiple places. And another thing which is in terms of performing queries. So you can have top one queries, and you basically be able to make sure that you pick up the queries which are yielding the appropriate result, not unpredictable results. So for example, like this query select top one star, it is actually an unpredictable result. So you just, if you are really sure that you wanted to perform this query, then it's okay. Otherwise, just make sure that you add more filters around, and do specific filters, so that you'll be getting the data according to your need. There are three important pieces which we have. We have something called recommendation generator in terms of the data type. So this is something that you can go for. It's a notebook which is available on um, GitHub, so you can utilize that. There is a statement generator which I have just opened for you. So what statement generator does is basically um, it has a Cosmos DB. One second, let me just bring up. Yeah, so Cosmos DB document sample, you can post it here. You can just I just extracted out the sample which uh, demonstrated by Sandeep. So this sample I have just pasted here, and I can just say generate with clause. So what it does is basically it will create a open row set for me. So here's the thing. So he had this particular
Manish, I think
uh,
your screen is not showing. We're still seeing your PowerPoint.
okay, sure. Yeah, sorry for my bad.
Yeah, now we can see.
So
Thank you.
perfect, thanks. So once you open the link, you'll see that you'll able to specify the container name, and then you can copy paste the sample document sample which you have, which you are going to be available in Synapse link. So what you can do, you can just copy paste one sample and then click on generate with clause. Here, what it does is basically it will generate the complete open row size statement and provide you the complete structural information, so that it'll very easy for you to identify, okay, what is the data type and how what is the schema look like for my Synapse link. So this is one of the thing which you can look at. Further down the line, we have query optimizer, and this is something that you can use. So once you have a recommendation generator which is set up here, in your Synapse workspace, you can execute this query, and then this query will actually give you the actual size of the columns which need the optimization. Another set of optimization is in terms of you can use OpenJSON function to expose nested JSON data. I'm sure that you have multiple nested JSON data as well. So here is what is being performed. So let's say if you have this data, which is uh, you know um, so it's basically generating a lot of specific documents, and what you can do, you can, let's say if you pick up this nested document, you'll able to get the schema beneath. So this is how the schema look like for the nested one. Make sure that you not always say nvarchar max, and you have simple SQL Server specific scenarios where you can specify max, but the recommendation is not to use max. You can just pick up something uh, which is very close to what you are expecting from your data. In terms of underscore ID, so you understand that we support Mongo API, and MongoDB always have ID and underscore ID, which is basically a unique field for that particular partition, and it is consistent of object ID. So what you can do, you can basically specify something like this, and something specific to this one. And then, in this SQL statement, you can basically say varchar whatever the size you're expecting for your field. Some pointers. JSON doesn't have built-in data type, hence Cosmos DB also does not have that. But definitely you can go for some validation, and you can read Synapse runtime. And if you want, you can convert, or you can have JSON in a string data type column. That could be the one thing. Otherwise, you can convert it, as I mentioned, that you can convert this string to actual datetime. So your queries into Synapse will be utilizing the datetime capability of Synapse. Um, so there are few more things which is critical for T-SQL perspective. So let's say if you have a T-SQL joins. So there are two type of stuff you can go for. One is cross apply and second is outer apply. In cross you have no root. I mean, depending upon what is your specific requirement, you can have uh, you know. um um, like a kind of left outer join and right outer join kind of thing. You can consider here. This is very specific to Synapse, and you can utilize it. Another thing which is important in terms of serverless. Let's say if you are using serverless tools, it requires you to have like there is a warm up time, which is making a 20% slower because of the static stick reading. And then if you want to avoid this kind of thing, you can keep the service running so that you don't need to wait for warm up time. Um, Apart from that, in Cosmos DB transactional store, there is a partition key, but that partition key is I mean, it can be different from Synapse Link, and you can model your transaction data in a different, partition key altogether. So you can have, both the different partition key. Another pointer which is related to the TTL, just make sure that you don't have transactional TTL as less than 2 minutes. The data will be archived and it won't be represented into analytical store. So there should be a time like less than 5 minutes. As your 5 minutes as your standard. So you should not have TTL of less than 5 minutes in ideal scenario. Um, and we don't support for backup, like backup analytical store backup is not there. And you can just, if you want, you can read the data and push it to blob storage if you want to create a manual backup. Um, you can use with clause and you can, expose the next queries by specifying the correct data type. Also, select star query will you'll have a lot of uh, you know uh, overheads. So try to avoid this and just make sure that you have where clause and don't scan all the data. That's one of the important thing. And whenever there is a need, then you can create a view and you can query sys column for checking up the data types. So it will be easier for you to identify. Um, Another set of best practices start from auto schema merge. If your schema is getting changed frequently, then and you want that changes has to be replicated into uh, sorry into in analytical store. Hence, what you can do, you can use auto schema merge option true, so that it will automatically reflect. We have CI/CD. You can connect workspace here like GitHub, and you'll be able to perform the stuff easily because Spark data frame is there. So if you are using data frame, then you can use filter and where. And all the predicates are basically pushed onto storage. So this will avoid the unwanted data coming up. And one of the important thing is basically when using OLAP, then query custom is something that is not available with Cosmos DB. Here is a set of labs which is available. You can go ahead and you can try it out. And I would like to thank Data Platform Geeks and SQL Server Geeks for their community initiatives. And we are here to, for any questions, anything you have, any doubt you come across. With that, thank you so much.
Thank you.